How y'all doing today?
Good.
All right. Hey, there's Chloe. How you doing, Chloe?
Not good, but I'm trying.
Well, you made it. Yeah, I just sent you an email. I got your exam too, but it was a blank document. So if you can re-upload it for me. And your quiz 2, I didn't get it, but about half the class didn't turn in their exam and quiz 2. So I'm going to give y'all another few days to get that uploaded. Let's see. Geo, you're here. I'm missing your quiz 2 and exam 2 as well. Can you get that in?
Yes, sir. Not yet. During the lecture, my laptop had died and I didn't have a charger whenever I was on Zoom.
Well, that's okay. If you ever miss class like that, you can always go to Canvas.
Recording.
It's in the files under lecture notes. And in the lecture notes, you can find the quizzes and the exams. So
Oh, yeah, sweet.
yeah, I'll show you right here where you can find it. So I go here, go to files. And then lecture notes. So yeah, under lecture 2 here, you'll find the exam and the quiz there. I usually get the lecture notes up pretty quickly after class. The video recordings of the lectures, that takes me a few hours to get uploaded sometimes. But you can always find that under the syllabus. YouTube and notes, just click on YouTube right here. That'll take you to the first lecture video, and I put them in a playlist, so hopefully you can find the playlist from there. We have 1, 2, 3, 4, 5, 6 out of 2, 3, 4, 5, 6, 7, 8, 9 out of 10. All right, 6 out of 10, more than half. All right, well, let's see, let's move on with it then. Alex loaded. Get this book going. Let's see where we left off last time. I already have that one open. Lecture 2. Let's see. So yeah, this was exam 2. And where did we leave off? We left off on dividing signed numbers. The division of integers. Okay. Let's see. Operations in algebra. No, we haven't gotten that far yet. Hold on. Let's see, such 2, 3. We did 2, 3. Yeah, we did that. Let's see. This Alex is kind of difficult to navigate, but I'm sure I'll figure it out. That's homework. Multiplication. I don't remember doing this. Let me look at that lecture again. page 99. Okay. So we made it page 99. Which is this 39? That does, oh, 96. Okay. 98. Page 99. All right, this is where we left off. So we'll pick up right here on page 99. Let's check out their little lecture video. Open that in a new window. And play.
In this video, we practice dividing integers. First, we have 40 divided by -4. The quotient is negative because the dividend and divisor have different signs. The quotient is -10. Next, we have -36 divided by -9. The fraction bar represents division, and we have two numbers of the same sign. So the quotient is +4. The third example is -33 divided by +3. The quotient is -11. The last two examples investigate division involving 0. We have 0 divided by -2, and 0 divided by any non-zero number is 0. We can check by noting that the quotient 0 times the divisor -2 gives us 0. The last example is -4 divided by 0. The quotient is undefined because no number when multiplied by 0 gives us -4.
All right, so we'll go into this in more detail. Division is the area that usually gets people the most here. So let's see. Here's that one. This one. So division of integers. All right. When we divide two numbers, we can check our result by using multiplication, because multiplication and division are related in this way. It seems reasonable that the same sign rules that apply to multiplication also apply to division. All right, so we say 6 divided by 3, or 6 divided by 3, or 6/3. These are all the same thing. We say that this is 2 because 3 times 2 equals 6. All right, so they're asking how many times will this number fit into that number? Well, 3 fits into 6 twice. So that's how division works. Now for all these minus signs. All right, remember 3 divided by 3 is just 1. Okay. -2 over -2 is just 1. All right. Likewise, -1 over -1 is still 1. Okay. So keep that in mind. Now, if you have something like -2, that's the same thing as -1 times 2. All right. If you have -2 here, this is also the same thing as -2 divided by 1. 3 is the same as 3 over 1, right? Any number A is also A over 1, okay? When you have a fraction like, say, -2/3, look where I put that minus. I put it right in front of the fraction. That's the same thing as -2 over 3. The same thing as 2 over -3. Okay. So that minus, if there's just one minus sign, you can put it anywhere you want. Okay. And the reason why is because that minus is just a -1. This is a -1 times 2/3. So that's the same thing as -1 times 2/3 or 2 over -1 times 3. Just showing you that you can move that minus around, okay? And it's because this 1, when you multiply by 1 or divide by 1, it doesn't change anything. You can take any number and say, oh, here's a 6. That's the same thing as 6 times 1, right? You can always throw that 1 in there anywhere. Now, when it comes to the minuses, just like when you multiply, a -1 times a -1 is +1. Okay, so 2 minuses make it positive. Remember, throwing that minus in there makes you turn in the opposite direction. So this says turn to the left, and then it says turn back to the right towards your positive numbers. So if we have like, let's say a -6/3. Well, we have a minus sign, so we have to keep that minus. And then 6/3 is 2. Okay, so that's the same thing whether I said it's 6/-3 or -6/3. It doesn't matter. We have a minus, and then 6/3 is equal to 2. Now, if we have 2 minuses, what if we have a -4/-2? Okay, that's the same thing as saying -4/2. And the 2 minuses cancel and make it a positive. Okay, I could rewrite this like I could say I can move that minus up. This is the same thing as -4/2. It's also 4/-2. Either way, you're going to get 2 because the 2 minuses cancel. Okay. Any questions about that? All right, let's look at an example here. Oh, hit the wrong program. Hold on. There we go. One, two, three, four, 5, 6, 7. All right, 7 people have made it. All right, the quotient of 2 numbers with the same sign is positive. All right, so 20/5. Since they're both positive, the result is positive, and this is 4 because 5 times 4 makes 20. Okay. All right, now if you have both negative, -20/-5, that's still positive 4. All right, these 2 minuses cancel one another out. -1/-1 is just 1. Okay, so a minus over minus still gives you a positive. Now, if you have 2 different signs, you're going to end up with a negative. So if you have 16/-8, right, you still have that minus sign, and 16/8 is 2. All right, and then they say, well, what about -16/8? Well, they're equal. You can move that minus from the top to the bottom. You can move it around however you want. All right. Now for 0 divided by 12. How many times can you stuff 12 into 0? 0 times. You can always take 0 and divide it by anything. You're going to get 0. All right. 0 divided by -3 is still 0. That's the thing is +0 is equal to -0. They're one and the same. All right. But now what about this one? -5/0. This is undefined.
Undefined.
You can't divide by 0. It doesn't make any sense. All right, so why does that not make any sense? You might think, well, 0, shouldn't it go into -5 an infinite number of times, right? Since 0 doesn't take up any space at all, right? Let's look at numbers really, really small real quick. So here's our number line. Here's 0, here's 1, here's -1. All right, I did this example last time, but I think it's important to do it a couple of times here. So let's say I'm taking 1 and trying to divide by 0. What is that? Well, we already said it's undefined. Well, to find out why, let's look at numbers really, really close to 0. What if I look at 0 divided by 0.1? Right? Well, that's going to be 10, right? This is, instead of a decimal, let me do like that. 1/10, that's the same thing as 0.1. If you take a 10th and put it into 1, you're going to get 10. So here's like a 10th right here. Here's 1/10. So let's put in something even smaller. 1/100th. So that's right about here. That's small, right? You're going to get 100. Now, if I divide by 1,000th, I get 1,000. All right. So as these numbers here get closer to 0, and I'm going to put a little plus sign here. That means I'm putting numbers in that are getting smaller and smaller and smaller, but are positive. Then this number here gets bigger and bigger and bigger to positive infinity. 1 divided by a teeny, 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 tiny number that's positive is going to give me a really big number. Well, what happens if I plug numbers in over here that are closer and closer to 0, but negative? What if I do -1/10? Well, I'm going to get a -10. See, that's a pretty small number, but it's negative. If I do -1/100th, I get a -100. If I do -1/1000th, I get a -1000. So I'm plugging numbers in here that are getting closer and closer to 0 because I want to find out what happens when you get to 0. Well, if these numbers get smaller and smaller, I'm going to call it 0 minus. Numbers really tiny, getting closer to 0, but they're negative, then the fraction goes to -infinity. So what we're seeing here is that if you plug numbers in closer and closer to 0 that are negative, well, then this thing is -infinity. But if I plug numbers in closer and closer to 0 that are positive, well, then I get positive infinity. So I'm just going to say positive or -infinity. And there's not two numbers further apart than positive and -infinity. So if you take anything and divide it by 0, you're getting both positive and -infinity. That's why it's undefined. It just doesn't make sense to divide by 0. Now, yes, you can take 0 and divide it by anything you want. You get 0. 0 can be on the top. It cannot be on the bottom. Okay. If it's on the top, it's 0. If it's on the bottom, it's undefined. And there's ways of getting around that in calculus and such. It's kind of fun. You know, methods like I just showed you. Well, if you can't plug in 0, let's plug in a number that's infinitely close to 0 and see what it does, right? All right. Oh, I never did these problems, did I? Okay. Oh, yeah. Okay. Back to Alex. Actually, we need to do our quiz. Enough of y'all are here now. 1, 2, 3, 4, 5, 6. All right, let's do our quiz. This will be quiz number 3. Number 1. Let's see. Simplify. Let's see, -2 times 3 plus 4 times a -5. Number 1, there's number 2. I guess, hold on, you all haven't done problems like this yet. Let me change this. Let's run division. I'm just gonna do a bunch of addition. I'm gonna do a -2 plus -3 plus 4 plus -5 minus 1. Okay, this is all addition and subtraction. So now let's look at one that's all multiplication. -2 times 3 times 4 times -2 times a -1. All right, so simplify both these expressions. It's 221. We'll take, see, how long do y'all need? 10 or 15 minutes? Y'all pick. Can you handle that in 10? We'll do a 10-minute quiz. So I'll put you in your breakout rooms. Feel free to work alone or work with one another, whatever you're comfortable with. And we'll come back at 2:31 and we'll work these problems together. So let me find your breakout rooms. I mean, there's only, what, 9, 10 people in the class? We have a very small class. So if you can, try to get to know one another, help one another out. Usually getting to know one another helps with anxiety in the classroom, and math brings out more anxiety than any subject. It's 2:22 now, so at 2:32, we will work this quiz. There we go. All right, let's check out this quiz. So this first one here is a bunch of addition and subtraction, right? We work from left to right. See, a -2 and a -3 give us a -5, right? Now a -5 plus 4 would put us at -1. Now a -1 and a -5 would put us at -6. And a -6 and a -1 puts us at -7. So this is going to be -7. And I'll put a red box around that. Is that what y'all got?
I did.
All right, good job. All right, these are the easy ones because we're only doing one thing or the other. This one here is a bunch of multiplication. In the next ones, we're going to be mixing addition, multiplication, and division and such. So it's going to be fun. Now for multiplication, remember a minus times a minus gives us a +1, right? So those two cancel, but then we have another minus. So there's 3 minuses total. Now, since everything is being multiplied together right here, we could say, pull out all 3 of these minuses. This is a minus, okay? And then we have 2 times 3 is 6. And then we have this times here. 4 times 2 is 8. And then we still have a 1. Okay. So multiplying by 1 doesn't change anything. 8 times 6 is what, 48. Yeah, 48, negative 48. All right, is that what y'all got? 2 times 3 is 6, times 4 is 24, times 2 is 48. And there's 1, 2, 3 minus signs. So that leaves us with a minus overall. All right. There's lots of different ways you can do this problem because everything is multiplication. You can rearrange this in any order. Okay. Any questions about this one? All right. If you're having issues with these, you need to practice, practice, practice.
I didn't necessarily got it right, but I see how you got it.
All right. Yeah, we have 3 minus signs. 2 of them cancel one another. That leaves us with a minus. And then you just multiply all the numbers together. You do it any order you want. 4 times 2 is 8, times 3 is 24, times 2 is 48. Or you could do it like 3 times 4 is 12, times 2 is 24, times 2 is 48. Doesn't matter what order you do it in. So there's your quiz. Move on to the next section. Oh, all right. Alex didn't kick me out. Okay. So back to division. Okay, so, oh, they have another video for us to watch, don't they? Is that a new one? Yeah, well, let's watch their little video. Open link and new window. And play.
We now focus our attention to the division of signed numbers. Recall that any division problem can be checked by multiplication. For example, 18 divided by 3 is 6 because 3 times 6 equals 18. Because multiplication and division are related in this fashion, the same rules that apply to multiplication must also apply to division. That is, the quotient of 2 numbers with the same sign is positive, and the quotient of 2 numbers with different signs is negative. So, for example, negative 20 divided by negative 4 is positive 5. The quotient negative 18 divided by positive 2 is negative 9. Now we also have 2 important rules involving 0. First, 0 divided by any non-zero number is 0. For example, 0 divided by 6 is 0. We can check this result by multiplication. The quotient 0 times the divisor 6 gives us a dividend of 0. Now let's look what happens when we reverse this. That is, when we divide a non-zero number by 0. For example, 8 divided by 0. The quotient is undefined, and let's see why. I'm going to recopy the problem, and I'm going to put a question mark in place of the quotient. To check this result by using multiplication, we'd have question mark times 0 equals 8. Well, no number when multiplied by 0 will give us 8. And we say that the quotient is undefined.
All right, so let's see. All right, so it just went over what we just went over a while ago. When they say the quotient, they mean the fraction. When you take 42 and divide it by 7, that's your quotient. All right. So 50 divided by -5. All right, we have a minus sign, so we keep it. And then 50 divided by 5 is 10 because 5 times 10 is 50. Now here in part B, there's a minus over a minus, right? When it comes to fractions, remember 2 over 2, that's just 1. 3 over 3, that's just 1, right? And if you take anything and multiply it by 1, like 2 times 1, you just get your number back. 3 times 1 is just 3, right? So using these two facts, a -1 over a -1 is just 1. If the top and the bottom of the fraction are exactly the same, then it's 1. And then multiplying by 1 doesn't change anything. So what we have over here is we really have a -1 times a 42 and a -1 times a 7. The -1 over the -1, that's just 1. So we're really looking at 1 times 42 over 7. And multiplying by 1 doesn't change anything. This is just 42 over 7. So basically, two minuses, they cancel one another out. And 42 over 7 is 6 because 6 times 7 is 42. Part C, we have a minus. Keep your minus. 3 goes into 39, 13 times, because 13 times 3 is 39. Here we have 0 divided by -7. How many times can you pack any number into 0? 0. Right? 0 divided by anything other than 0 is 0. So 8, E here, -8, this is undefined because you cannot divide by 0. Remember what they did, the trick there? They said, if this equaled something, then that would mean that 0 times our something would have to be -8. But there's nothing you can multiply 0 by to get a -8. And that's why it's undefined. All right. Do our tip and our skill practice here. Oh, and I assume y'all all got the email or heard it elsewhere. We have another week of remote classes. So next week we're still doing Zoom. Okay, hopefully after that we can come to class, but we'll see. All right. So divide. All right, number 14, we have a -40 divided by 10. There's a single minus sign, so we keep it. 40 divided by 10 is 4, because 10 times 4 is 40. Number 15, the minus over the minus cancels. They go away, right? Because that's the same thing as -, 36 over 12. So the -1 times a -1 is just +1. And this is going to be 3 because 12 times 3 is 36. Number 16, it doesn't matter if the minus is on the bottom or the top or out front of the fraction. It's a single minus sign and we need to keep it. This is a negative number and it's a -9 because 9 times 2 is 18. Number 17, this is 0 divided by -12. You can pack -12 into 0 times, right? 0 divided by anything other than 0 gives you 0, all right? And 18, undefined. You cannot divide by 0. All right, so 0 over 3, again, is 0. 3 over 0, undefined. In mathematical physics, when dealing with black holes and things like that, we end up with 0 over 0 in our equations. What do you do with a 0 over 0? Well, it turns out that things like this, you can actually finagle and sometimes get some information out of it, because it's not the end result, the 0 over 0. It's more about how it came to be a 0 over 0. And in that journey, you can find a lot of information about the universe. Example 6, let's check out their little video here. Open it in a new window. Oh, sorry about that. Play. There we go.
In this video, we have 3 English statements that we need to translate to mathematical expressions. The first is the quotient of 40 and -20. This represents 40 divided by -20. Since the dividend and divisor have different signs, then the quotient is negative. Simplifying, we get -2. The second statement is -16 divided by -4. The dividend and divisor have the same sign, so the quotient is +4. Finally, the third statement is -2 divided into 18. This means that we start with the 18 as a dividend and divide by -2. The quotient is -9.
All right. So, oops. Okay, translate the phrase into a mathematical expression, then simplify. The quotient of 26 and 13, -13. What they mean here is 26 over -13. That's the quotient. They just mean the fraction. Okay, so we have a minus, we need to keep the minus, and then 26 over 13 is 2, because 13 times 2 is 26. Part B here, they have a -45 divided by 5. So we have a single minus, so we need to keep our minus. And then we have a 9, because 9 times 5 is 45. Part C, -4 divided into -24. See, notice how they, yeah, they changed that one little word to mess with you. Okay. All right, -4 divided into a -24. So, all right, keep those in mind. So we have 2 minuses, they cancel one another out. So we're left with a +6. All right. Yeah, the minus goes away because 6 times 4 is 24. If you think about it, why is if let's say I divided -1 into -3, I'm going to get a +3, right? Here's -1, -2, -3. Why is that a +3? Well, here's your -1, right? Well, how many times will that go into this? Well, once, twice, 3 times. Positive 3 times, okay? That's why a negative into a negative is a positive. Let's look. More skill practice here. Okay. Translate the phrase into a mathematical expression, then simplify. The quotient of -40 and -4. The 2 minus signs cancel. We're left with a +10 because 4 times 10 is 40. Number 20, we have 6 divided by a -3. Well, we have a single minus sign, so we need to keep it. Then we have a 20 because 3 times 20 gives us 60. -8 divided into a -24. The 2 minuses cancel and we get 3 because 3 times 8 is 24. And another video. Applying division of integers. Let's see what they have to say. I'll remember to hit play this time. There we go.
Between 6 p.m. and 12 a.m., a cold front passed through and the change in temperature was -12 degrees Fahrenheit. We need to find the hourly change in temperature. To do this, we'll assume that the temperature dropped evenly over the 6-hour period. This implies division. We have -12 degrees divided by 6 hours, and this simplifies to -2 degrees per hour.
That's an example word problem. There we go. So right here, between midnight and 6 a.m., the change was -18 degrees. Find the hourly change in temperature. Well, between midnight and 6 a.m., that's 6 hours, right? We had a change of -18 degrees Fahrenheit in 6 hours. So we just simplify this expression. There's only one minus sign, so we have a negative. 18 divided by 6 is 3. 3 degrees Fahrenheit per hour. All right, so this turns into the 3. Then we have to keep the degrees Fahrenheit and we have to keep the units of hours. All right, so this is -3 degrees Fahrenheit per hour. Okay. You always want to write your units. These are our units, the degrees and hours. You know, sometimes we'll have centimeters or meters or dollars. You always want to write your units down because they kind of guide your math. If you start off with degrees Fahrenheit per hour and you end up with pesos, you know you did something wrong. Okay. You want to always write your units because they guide you. Let's look at 22 here. A severe cold front blew through Atlanta and the temperature change over a 6-hour period was -24 degrees Fahrenheit. Find the average hourly change in temperature. So when they're talking about, go ahead.
-4.
Yeah, we have -24 degrees Fahrenheit over 6 hours. 6 hours. So we keep our minus 24/6 is 4 degrees Fahrenheit per hour. Okay. Yeah, y'all know how to calculate averages, right? If I have a 2, a 3, a 5, and a 6, what's the average? Well, to find an average, you add them all up and divide by how many there are. So the average would be 2 plus 3 plus 5 plus 6 and divide by 4 because there's 4 numbers. All right, so that would be 2 plus 3 is 5, and then 5 would be 10, and then 6 would be 16 over 4.
4.
Yeah, so the average would be 4. This, it's kind of like a simple calculus problem. We're looking for the average temperature, right? The average change in temperature. Well, it changed 24 degrees in 6 hours. Okay. So we end up with -4 degrees Fahrenheit per hour. In the video, she said, assume that every hour it changes the same. So what this is saying is, it's not saying necessarily that it changed exactly 4 degrees every hour. Okay. What this is saying is the average change is -4 degrees. Maybe 1 hour it changed by 1 degree, and then the next hour it changed by 7. You know, the average is still 4. Okay, that's why we have to say it's the average hourly change, because we don't know exactly what each hour was. Each hour could have been totally different, but on average, it's 4 degrees. All right, so, okay, we are done this page. For 2.5. All right, let's get a snapshot. I hit the, okay, I hit the button. All right, page 105. Oh, somebody asked me about the textbooks, and I got a lot of replies. Have a lot of y'all not gotten your physical textbook yet? I sent an email to the textbook representative, and hopefully I'll get some information back. Let me see if I heard from them about the books real quick. All right, the lady says, have students reach out to our Alex team or our customer service group because they will be able to look into each student's specific account and see when they are ordered, address tracking. Okay, so here, I'll just put this in an email to y'all. So if you're having issues getting your book, you'll have the information here so far that I have. Here, let me send that before I forget, because I will forget. So 0410 to students, all subject textbook. There we go. So if you're having issues getting your physical textbook, check your email. I just pasted what the representative sent me. There's a website and a phone number to call. So hopefully we can get everybody what they deserve here. All right. Order of operations applies when simplifying expressions with integers. All right, remember integers are just your numbers. First, perform all operations inside parentheses and other grouping symbols. Simplifying expressions containing exponents, square roots, or absolute values. Perform multiplication or division in the order that they appear from left to right. Perform addition or subtraction in the order that they appear from left to right. Okay, this order of operations stuff, they're gonna have you memorize all kinds of stuff. It's just a simple thing of doing a little bit of practice and you'll get a feel for it. All right, it's something you have to practice and develop a feel for if you're gonna be able to do it quickly. All right, they have a video for us to watch. Let's check out their little video here. Open a new window. Hey, stop it. I just ran out of dog food. My dog's going crazy. What happened? Oh, there it is. Okay.
In this section, we revisit the order of operations. The first example is -18 minus 5 times the quantity 3 minus 4. The first step is to do all operations within parentheses or other grouping symbols. So we'll subtract 3 minus 4 first to get -1 inside parentheses. We now have -18 minus 5 times -1. I can write this as -18 plus -5 times -1. We perform multiplication before addition or subtraction. So -5 times -1 is +5. So now we have -18 plus 5, which is -13. The second example is 22 plus 36 divided by 3 times -2. I need to perform multiplication or division in order from left to right before addition. So the first step is to divide 36 by 3. This makes the expression 22 plus 12 times -2. Again, I'll perform multiplication or division before addition. 12 times -2 is -24. So the expression becomes 22 plus -24. And this gives us a grand total of -2.
Okay. So let's they say simplify this, right? So they say do the stuff inside parentheses first, right? So let's see, we have a -12 minus 6 and then 7 minus 5. We do that first. So 7 minus 5 is 2. Okay. So you always want to do your multiplications before additions. All right, multiply first. So right here we have a -6 times 2 is a -12. Now we have -12 minus 12 is a -24. So if I say 3 times 2 plus 1, all right, I have to do the multiplication first and then the addition, okay? So here's one example. Another example, if I have 3 times 2, if I do this, 3 times 2 plus 1. All right, well, I said multiplication first, but this has parentheses. In this case, we have to do parentheses first. All right, so 2 plus 1 would be 3. And 3 times 3 is 9. So parentheses, then your multiplication or division, and then your addition or subtraction. Okay. Let's see. I'm going to do a lot of examples of this stuff. So our skill practice here. All right, so to simplify this, all right, let's do our parentheses first. We have an 8 minus 2. Now what's in parentheses? A 3 minus 10 would be a negative 7. Okay. So we've done these parentheses first. Now here, the parentheses, all we're meaning here is multiplying. All right. So what we have is an 8. Negative 2 times a negative 7 is not 17, it's 14. Minus, minus, again, we're multiplying here. A minus times a minus is a positive. So 8 plus 14 is 22. Remember, negative 2 times negative 3 is a positive 6. Negative 2 minus 3, that's going to be a negative 5. Okay. Multiplying, the signs cancel. And subtracting, if you have a debt and you add to that debt, you have more debt. Okay. So there's our skill practice. Yeah, let's check out this video.
In this example, we need to simplify the expression 5 squared minus 6 squared divided by the quantity -1 minus 2. I'll subtract inside parentheses first to get 5 squared minus 6 squared divided by -3. Next, I'll work outside the parentheses. I need to simplify the terms with the exponents before subtracting or dividing. Working from left to right, 5 squared is 5 times 5, which is 25. And 6 squared is 6 times 6, which is 36. So we have 25 minus 36 divided by -3. Division is performed before subtraction, so the expression becomes 25 minus -12. This is equal to 25 plus positive 12, which is 37.
Okay, so let's use what we learned here. Okay, so this symbol, I don't like it because nobody ever uses it when they do math. Okay, what we're looking at here is we have a 6 and a plus. 48 divided by 4. 48 divided by 4. And then we have times a -2. Okay. So we need to do our multiplications first here and our divisions. All right. This guy here, 4 divided by 48 is, what is that? 12. And then we still have our -2. All right. So I just simplified this fraction. Is all I did in that step. Now we do our
Negative 24.
Yeah, 6 minus 24. We want to do our multiplication before our addition. Now we get a negative 18. All right, we could have done that a little differently. I could have done this. I could have multiplied first 48 times a negative 2 is a negative 96. And then we have a plus and negative. And then 96 divided by 4 is a negative 24. Yeah. Which is still negative 18. Okay. Let's look at another example here. So number 2, they want to simplify this. So we need to do, remember, parentheses. When I say parentheses, I mean what's inside the parentheses. So here, negative 3 is inside parentheses. There's nothing to do inside of there. So we just treat it like multiplication. Now we want to do divisions and multiplications before we do our additions and subtractions. So we have a negative 10, a plus 24 divided by 2. That's, dang it, 24 divided by 2. And then we have times a negative 3. So all I did was rewrite this guy as a fraction. So now I still want to do multiplications and divisions first. I can either multiply these two first, or I can do this division first. It doesn't matter. You get the same answer either way. So 24 divided by 2 is 12. I still have a negative 10. I'm doing my multiplication now. 12 times a negative 3 is a negative 36. So if I have a negative 10 and I put even more negative onto that, I get an even bigger negative number, negative 46. So I want to give you a quick example. If you have 24 divided by 2 plus 1. All right, the parenthesis here, all right, is being applied to this symbol, this division symbol. When I say divide, it says divide by everything inside the parentheses. You see, this would be 24 over 3, which would be 8. See, that's different than if I didn't put parentheses. If I don't put the parentheses, well, I'm taking 24 and dividing it by 2, and then I'm adding 1 to that. Well, 24 divided by 2 is 12. So I'm getting 13. So you see what the parentheses do? When I put divided by, and then I put a bunch of stuff in parentheses, all right, this becomes one object. This is what goes underneath the 24 here, okay? That's why we use the parentheses. We have another video here. Link a new window. Play.
We take this opportunity for more practice with the order of operations. We have the absolute value of the quantity, negative 18 minus negative 2, all over 24 minus 4 squared. Well, the strategy in this example is to simplify the numerator and denominator of the fraction first. That is, I'll simplify above and below the division bars separately. In the top, the absolute value bars work as grouping symbols. I'll simplify within the absolute value bars. We have negative 18 plus positive 2. And this is negative 16 within the absolute value bars. The first step below the division bar is to simplify the exponent. 4 squared is 4 times 4, which is 16. So we have 24 minus 16. Next, up above, the absolute value of negative 16 is positive 16. Down below, 24 minus 16 is 8. So we have 16 divided by 8, which is 2.
Okie dokie. Let's see. Nope. All right, so watch that lecture video. So, all right, they want us to simplify. 3 squared is 9. Then they have a minus 10 squared divided by negative 1 minus 4. All right, so this whole thing goes underneath the 10 squared, right? So it gives me a 9 minus, all right? 10 squared is 100. Negative 1 minus 4 is a negative 5. So 9 minus a negative. All right, I can move this minus on the bottom. I can move it on the top or just out front. It doesn't matter. 100 divided by 5 is 20. So 9 minus a negative 20 is 9 plus 20, which would be 29. Okay, these problems, you need to practice a whole lot of them. You should get to where in a couple of weeks you can pretty closely do these in your head. All right, it just takes a lot of practice to where you don't have to think about every step anymore. All right, so by the end of the semester, you should be able to do problems like this, roughly in your head. So like this one here, I'd have some issues doing that in my head. I couldn't do 8 squared is 64. Then subtract 2 cubed. 2 cubed is 8. So 64 minus 8, but I need to divide the 8 by this first. So yeah, never mind. I don't expect you to be able to do these in your head, but I do expect you to be able to do them without having to think about every single step along the way. By the end of the semester, you should get enough practice to where you can do it kind of reflexively, kind of like talking. So here we have this 8 squared, right? That's 8 times 8, which is 64. Then we have minus 2 cubed is being divided by all of this stuff, negative 7 plus 5. Okay, so we got our 64. We still have our minus. 2 cubed is 8. Negative 7 plus 5 would be a negative 2. So again, we have a minus and a minus, which turns into a plus. The 8 over 2 becomes 4. So 64 plus 4 is 68. There you go. So example 4, there's a video. Let's check out the video.
In this animation, we'll simplify the expression using the order of operations. For each step in the process, your job is to click on the operation that should be performed for that step. For example, in the first step, click on the operation of subtraction within parentheses.
All right. What am I doing here? Do I hit play or next? I can't figure out what this example is doing. We go back to example 1, play. Okay, it just goes to the next example no matter what I click on. Okay, I don't understand this video, so let's just work some problems then. All right, so this guy right here, we have this absolute value. Boom. They work kind of like parentheses, but they also have that absolute value meaning. So inside of there, -8 and 24 would give us 16. Now I'm going to make these real big so you don't mistake them for a number 1. And I'm going to write my number 1 like this. There's no mistaking them. Now down here in the bottom, I need to do the exponents first. Remember, you do the multiplication before you do addition. Well, exponentiation is repetitive multiplication. So you have to do your exponents before you do your multiplication, because 3 squared is 3 times 3 is 9, okay? So if I had something like 2 times 3 squared, okay, this has precedence, all right? You have to do the exponent first. So this is going to be 18. You see, if you did the 2 times the 3 first, that would be wrong. All right, this exponent has precedence. So you do the exponents first, then your multiplication, then your addition. All right. All right, this is not 2 times 3, which would be 6 squared, because that would be 36. Okay. All right, to continue with part A here, the absolute value of 16 is just 16. Remember, absolute value asks you how far away is this number from 0. So 16 is 16 away from 0. On the bottom, we have a negative because 5 minus 9 is a -4. So since we have a minus, we have to keep it, and 16 over 4 is 4. Part B here looks really ugly. They got parentheses inside of parentheses. When they put square brackets, that's just a parenthesis. See, that it's nice to mix them, because it's when you get parentheses next to parentheses next to parentheses, it gets messy. So what I do is I alternate parenthesis, square bracket, etc. So we have a 5 minus 2. And this 2 is being multiplied by all of this. Okay. All of this right here is one big number. It's just a number. And we're multiplying it by 2. Okay. So this is 2 times. So we have to go to the farthest inside the parentheses. So we have to start in here and then work our way out. So I'm going to keep this bracket, keep the 8. And we're going to work our way from the inside out. So a -7 minus 5 is what, -12? Yeah. All right, so now we have a 5 minus 2 times. Inside here, we have an 8 minus 12, which would be a -4. We have a 5 minus, well, is this a minus? Hold on. We have a -2 times a -4. That's a +8. Okay, we have 2 minuses, they cancel. So 5 and 8 gives us 13. All right, any questions about this so far? Again, we can work these problems, but the only way you're going to learn this is by doing a lot of problems on your own. Like I said, math is not a spectator sport. You could watch me work 100 of these, but doing 10 on your own is going to do a lot more than watching me do 100 of them. All right, let's go back to Alex here. We're down this far. Skill practice. So yeah, make sure you're working as many of these homework problems in Alex as you can. Okay. All right. Number 4, we have an absolute value here. Let's figure out what this number inside is first. 50 plus a negative 10. That would be 40. That's the same as 50 minus 10. Now on the bottom, again, we got to do the exponent first. So 2 squared is 2 times 2 is 4. Okay. So the absolute value of 40 is just 40. We have a minus sign. 40 over 4 is 10. So one thing I want you to look at is negative 2 squared versus negative 2 squared. Right? Actually, let me do cubed. Cubed. Remember, when you have an exponent, it says you multiply the thing by itself that many times. So in this case, this is negative 2 times negative 2 times a negative 2. Minus minus cancel, and then we're left with another minus. 2 times 2 is 4 times 2 is 8. This is a negative 2 times 2 times 2. Which is also negative 8. So these happen to be equal, but for totally different reasons. This is why you can't just write down the answer and think that the student knows how to do it just because they got the right answer. You can do everything wrong and get the right answer. That's why showing your work is really important in math, right? If I change this to 4, right, I would have to change all this. This would be a negative 2, and this would be another 2. So this would be a positive 4, 8, 16. This would be a negative 16. Okay, because that exponent here, this whole thing gets multiplied by itself over and over again. Down here, only the 2 is multiplied by itself over and over again. All right, let's look at number 5 here. We have a 1 minus 3 times whatever this number is. And this number is 5 minus, what is 8 minus 1? 7, right? So I have a 1 minus 3 times 5 minus 7 is a negative 2. All right, and the square brackets, again, they're the same as the round brackets. They just change them for clarity. So I have a 1, negative 3 times a negative 2 is a positive 6. 1 plus 6 is 7. That's the skill practice. And did we watch this one yet? We haven't watched this one yet, have we? Open it in a new window. Play.
In this video, we'll simplify 11 minus 3 times the quantity in brackets, 10 plus 2 times the quantity, negative 5 plus 4 in parentheses. The expression has both parentheses and brackets. Recall that brackets play the same role as parentheses. They're grouping symbols. And we use them here because we have nested expressions. That is, we have parentheses within parentheses. So we'll work with the innermost parentheses first. I'll add negative 5 plus 4 to get negative 1. I'll recopy the rest of the expression. We have 11 minus 3 times the quantity, 10 plus 2 times negative 1. Next, I'll work within brackets. performing multiplication before addition. This is 11 minus 3 times 10 plus -2. Inside brackets, we have 8. So the expression becomes 11 minus 3 times 8. With the expression in brackets completely simplified, now I'll move outside the brackets. I'll multiply 3 times 8 to get 24. So the expression is 11 minus 24. Performing the subtraction, the final answer is -13.
All right, so let's see. How far do we have to go? 2. That's where we're at. We've been going at this an hour and a half now. Do y'all want to take a 10-minute break, restroom snack break, or do y'all want to just keep going?
We can take a break.
All right, let's take a 10-minute break. It's 3:30. We'll come back at 3:40. All right, class, we are back. And Alex has another video for us. Let's check it out.
In this video, we begin developing tools that will help us with word problems. A key skill is to be able to represent quantities algebraically. In our first example, we're told that the monthly cost for a health club membership is $40. We need to write an algebraic expression representing the cost for n months. Well, let's substitute some numbers first. The cost for 1 month is 1 times $40. The cost for 2 months is 2 times $40. And this, of course, is $80. The cost for 3 months is 3 times $40, which gives us $120. Hopefully, you can see the pattern that we multiply the cost per month times the number of months. So the cost for n months is n times 40, or simply 40n. In the second example, we have that Tom is 4 years older than his sister. If his sister's age is represented by the variable a, we need to write an expression representing Tom's age. Well, Tom is older by 4 years, so we can add 4 years to his sister's age. So Tom's age is represented by the algebraic expression a plus 4.
Okay, so all they're saying here is we're using some letters, right? If, who was it? Angie is 4 years older than Tom. All right, then all they're saying is Tom's age equals Angie's age plus 4. But writing out Angie's age is a whole lot. So they just said, let's just call this the letter A for age. All right, when you see letters mixed in with numbers, the letters represent numbers. It's just sometimes we don't want to say what that number is. Like the other example, in months, $40 a month. They say it's $40 a month. How much does it cost for in months? Well, it's just because they don't know how many months a customer is going to want. Is the customer going to want 3 months or 10 months or 1,000 months? You know, you could print out a whole book of this. 1 times $40, 2 times $40. All right, this was 40. This is 80. And you could go on forever with this whole book. Or you could just say whatever number of months, it's that times 40. So, you know, if the guest says 8 months, then the guy behind the front desk says, okay, in is 8. I just multiply 8 times 40. All right, let's look at their examples here. I'll recopy this. All right, so we use variables are used to represent quantities that are subject to change. For this reason, we can use variables and algebraic expressions to represent one or more unknowns in a word problem. Let me tell you, one thing that helped me learn math was reading a book about the history of math. So if you can find, you know, you don't have to read a whole book, but if you're into history, most of history is written based on wars. Who killed who and who won, and then who killed who and then who killed who. It's kind of boring and political. Whereas if you read history based on science, the history of science, specifically mathematics, then you will get a much better understanding of the evolution of the human race over the years. Because yeah, often, you know, whoever has the best math comes up with the best technology and wins the most wars, but that's not always the case. All right. And plus, a lot of this math came about by smart people, but they weren't necessarily geniuses, you know. They just had a particular problem that they're trying to solve, and mathematics kind of came out of it. So kind of reading about the minds that produced this stuff in the past is really interesting, because then you actually see the context where this all came from. You know, we didn't just sit down one day and come up with all of this stuff. You know, it took thousands of years, evolving a little bit at a time. So the way we wrote math, you know, 200 years ago doesn't look anything like how we write it today. You know, back then they might not have used letters. They might have wrote a whole word like I did up here, this kind of stuff. And then they found, well, I can just shorten that, and instead of writing a whole list of an infinite number one of these, I'll just let this symbol represent a number. And so all this stuff came out of need over time. So let's see, 5A, at a discount CD store. Wow, I didn't know they still sold CDs. Each CD cost $8. This is outrageously expensive. Suppose N is the number of CDs that a customer buys. Write an expression that represents the cost for N CDs. Well, if they're $8 each, right, the cost is going to be N times $8. That's it. Or we could write 8 times N dollars, or we could just write $8N. Those are all the same thing. We could say $8 times N. All we're doing is multiplying two numbers. N is the number of CDs, and then the number 8, and then you throw a dollar sign in front of it. So part B here, the length of a rectangle is 5 inches longer than the width W. Write an expression that represents the length of the rectangle. Let's let L to represent length. All right, the length is 5 inches longer than the width W. So if we take the width and add 5 inches to it, we get the length. It's that simple. The length is the width plus 5 inches in English. It's just a whole lot shorter than this whole sentence, right? We just said this whole sentence in 1, 2, 3, 4, 5, 6 symbols. All right, moving on. I can get a snapshot here. Skill practice. All right, smoked turkey costs $7 a pound. Write an expression that represents the cost of P pounds of turkey. All right, well, the cost is going to be $7 times the number of pounds. That's it. Later on, you'll see functions. You'll see things like this. C of P equals 7 times P. Later on, when we talk about functions, you're going to see stuff like this. And when you do, they do not mean multiplication here. What they mean is a function. They mean the cost depends on the number of pounds. And this is the cost. And you can see the dependency of the number of pounds here. Okay, we haven't gotten that far yet. I'm just letting you know a heads up that in the future, you might see stuff like this and it'll be a function. Okay. Just keep in mind that sometimes these parentheses mean something other than multiplication. But for now, and the way you figure that out is by context from practice. It's like when you read the word record versus record, you know how to say it based on the sentence. Okay. So number 7 here, the width of a basketball court, I'm going to call that W, is 44 feet shorter than its length L. Write an expression that represents the width. I'll let W be the width. So it's 44 feet shorter than its length. So if we take the length and take away from that 44 feet, that gives us the width. All right, example 6, they give us a little video to watch. So let's see what they have to say here.
In this video, we continue building skills to translate English statements into algebraic expressions. The first example is a sum of x and 8. The word sum means addition, so this is represented algebraically as x plus 8. The second expression is the product of -3 and t. The word product implies multiplication, so I'll write the algebraic expression as -3 times t, or simply -3t. Next, we have 4 subtracted from y, and we have to be careful of the order here. We need to start with y before taking 4 away from y. So the order of subtraction is y minus 4. Finally, the last example is twice the difference of 8 and x. The word twice means 2 times something. In this case, it's 2 times the difference of 8 and x. I'm going to enclose the difference in parentheses so that we take 2 times the entire difference. So we have 2 times parentheses 8 minus x. Now, if you had mistakenly not used parentheses, the expression would be incorrect.
All right, so you can imagine, let's see, the way they say this, the product of -6 and x. Well, 2000 years ago, before they even had symbols for numbers, if we had something like 2 plus 3 times 4 minus 1, the way they would have, you wouldn't have seen this on a clay tablet. You would have seen 2 added to the product of 3 with 4 and then take away 1. So thousands of years ago, math looked like this. Sucks, right? Imagine if you did anything even remotely complicated. What if you had several equations and you needed to put them together? Just basic accounting was a nightmare, without doing interest. And they didn't even have the number 0. So this is a lot better than this. All right. So the product of -6 and x. When I read this, I really have to think about it. But all it says is the product of -6 and x. We're just multiplying them together. This I look at and I recognize immediately. This I look at it and I go, okay, what does this mean? I have to translate it to this before it really makes sense to me. All right. I guess for y'all, just learning your math, this probably makes more sense. P subtracted from 7. Well, you got 7 and you're subtracting P from it. I guess this is more complicated for y'all than this, but we need to get you over across the bridge. Okay. The quotient of C and D, the quotient just means the fraction. And the one that comes first, they want on top. Twice the sum of y and 4. We have to put the parentheses because we're adding these numbers first and then doubling. Okay. Okay. That's what we want. It is not twice y and then add 4. Those are not equal. If you plug in a number, let's say I plug in a 1 for y. 1 plus 4 is 5 times 2 would be 10. But over here, if I plugged in 1, I would get 2 times 1 is 2 plus 4 is 6. 2 totally different results. Okay. So we're twice the sum. So what are we doubling? We are doubling all of this. Maybe they should have put parentheses there, right? Okay. Let's get a snapshot of this going on. My dogs should be happy. They just got big old cans of chicken breast. They ran out of dog food. I have a mouse and a rat invasion in my house. They've come in just all of a sudden. I don't know how many there are, but all night long, all I hear is eat, 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 and scuffle, scuffle, scuffle. I got up to go use the restroom, and this little mouse or rat hauled butt across the floor so fast, it was just a faint little shadow. Choom! I put out traps and poison, and they're just too smart. They get the bait off the trap without snapping it, and the poison, they know better. I need to get another cat, I guess. Okay, what are we doing? Okay, paste this. There we go. So with each phrase, write each phrase as an algebraic expression. The quotient of W and -4. 11 subtracted from X. The product of -9 and P. 4 times the sum of M and N. All right. So this is 3.3 here. The value of an algebraic expression depends on the values of the variables within the expression. Yeah. Okay. All right, let's check out their video. Boom. And play.
In this video, we'll evaluate the expression 5a minus b for a equals -3 and b equals 8. This means it will substitute -3 for a in the expression and 8 for b in the expression. Now, it's always a good idea to first use empty parentheses in place of the variables before substituting the numerical values. So now I'll input -3 and 8 inside the parentheses. So now we have 5 times -3 minus 8. I'll perform multiplication before subtraction. So we have -15 minus 8, and this is -23.
All right, so all we're doing here is learning substitution, okay? So evaluate the expression for the given variables. They say, here's 3x minus y. And they say x is 7 and y is -3. Well, if x is 7 and y is a -3, all we do is replace our variables with the numbers. That's it. So 3 times 7 is 21. A minus becomes a plus. And we get a 24 here. So these X and Y, we could have used A and B. We could have called them Tom and Sam. You know, we can use anything we want. It's just X and Y are the first letters that pop up in most people's heads when they're doing math. So let's see. Another snapshot here. We need this. Boom. Okay. Evaluate 4a plus b for a equals 8 and b is a -52. So all we did was replace a and b. 8 times 4 is 32. We have -52. So that would be a -20. All right, now we're in sample 8 here. We'll watch their video.
In this video, we'll evaluate 3 algebraic expressions for given values of the variables. First, we have the expression, the opposite of the absolute value of the quantity x minus y. We'll substitute -5 for x and 6 for y. I'm using empty parentheses first, and then I'll substitute the numerical values. I need to simplify within the absolute value bars first because they serve as grouping symbols. So we have on the outside the opposite of the absolute value of -11. The absolute value of -11 is +11. Then, taking the opposite, we have a final answer of -11. You might want to review this again because there's a lot of bookkeeping with the signs. In the second example, we have the expression t squared. I'll replace t by empty parentheses. Then I'll substitute -7 for t. Notice how important it is to use the parentheses. The parentheses help remind us that the negative sign and the 7 are both part of the base that's being squared.
What the hell?
So -7 squared is -7 times -7 which is positive 49. The third example is a good contrast to the second example. Here we have the opposite of c squared. I'll replace c with empty parentheses, and notice that the negative sign is still out in front. So we have the opposite of the quantity -4 squared. I'll square -4 first, which is -4 times -4, to get positive 16. But then we still need to take the opposite, so the final answer is -16.
All right. So let's look at some of these examples here. Evaluate the expressions for the given values of the variables. So all we're going to do here is take -6 and replace z with it, okay? So we have a negative absolute value of -z. So negative absolute value of negative, z here is a -6. All right. So working inside of here first, let's keep our minus. -6 is +6. So we keep our minus. The absolute value of 6 is just 6. So all of that is just -6. This one we have an x squared. Now we replace x with -4. So we need to put parentheses here because x is being squared, right? This is x times x, right? So if we didn't put the parentheses and we left the minus out, then the squared would only be applying to the 4. That's why we need these parentheses. So the squared applies to the whole thing, right? This is -4 times a -4, which would be a +16. Okay. Now this one's different. Notice there's a minus outside. Well, it's really not that much different. It's the same as the previous one because we're still replacing y with a -6. So we have a minus, replace y with a -6. Okay. So this previous one, there wasn't any minus sign, right? So there's no minus sign in front of the parentheses. Here we have this extra minus. Okay. So let's keep our minus. And a -6 squared, that's -6 times a -6, right?
-36.
Right, we still have this minus. -6 times -6 is 36. All right, so problems like this, you should be able to get to where you can do these in your head. All right, you're taking -6, squaring it, and then throwing a minus in front. So a -6 times a -6 is +36. And then a minus makes it -36. That was example 8. Over here. Okay, page 109. All right, we have a negative absolute value of a -y. And y is -12. So we have a negative, negative, and then we're replacing y with a -12. Okay, so we keep our minus. What's going on inside of here? A -12 is just a +12. We have our minus. The absolute value of 12 is 12. Okay. P squared for p equals -5. Just replace p with a -5. So when we square it, we're multiplying it by itself twice. Gives us a +25. This one, just like that last time, there was a minus here, a -w squared. Well, we have a minus, and they say that w is -10, so we put -10 is what's being squared. So we have our minus,
Negative 100.
right? Negative 10 times a negative 10. We got 1, 2, 3 minus signs. 10 times 10 is 100. All right, here, look at this one. This one has all kinds of stuff. We got a negative 5 x minus y plus z all inside the absolute value. Well, they say that x is negative 9. Then we have a minus, right? Minus. And then y. Y is a negative 4. Then we have a plus sign. And then z. They say z is 2. So we have a negative 5. Now what's going on in here? This is negative 9 plus 4. That would be a negative 5. Plus 2 puts us at a negative 3. So the absolute value of negative 3
15.
is 3. All right, but we still got a minus here. So it's going to be a minus 15. So absolute value bars act as grouping symbols. Therefore, you must perform the operations within the absolute value first. And skill practice. All right, evaluate the expression for the given value of the variable. We have a 3 minus absolute value a plus b plus 4. And they say that a is negative 5, b is negative 12. All right, we have 3 minus, so what's going on inside of here? Negative 5 plus a negative 12. That's negative 17. 17. All right, negative 17 and 4 would be a negative 13. The absolute value of negative 13 is just 13. Dang it. Okay. Oh. And then 3 minus 13 would be a negative 10. And let's see. 0.5 exercises. What the hell is this? Next page. I don't know, this book is weird. Here goes the next page. Section 3. So that's what we needed to get covered for the week. This gives us a few minutes for our exam. It's going to be exam number 3. Problem number 1. Simplify. Let's see. 3. I'm going to do 9 divided by 1 plus 2. And then we're going to add to that 12 divided by 6 minus 4. What is that equal to? And then number 2, simplify. Simplify. There we go. Substitute and simplify. 2 minus x plus y minus 3. For, let's see, when x equals 1 and y equals 5. All right, so those are your 2 problems for the day. Get them in by midnight. I'll be here till 4:30. Once you have the test, you're welcome to leave the class anytime you want. If you need to talk to me one-on-one, just wait until everybody else is gone, or you have my number. You can always call me. All right. Well, that's it for today. Wait, to get the quiz and the exam, either you see it here in class, right? But if you miss class, you can always go to Canvas. Let me see if I could find Canvas. There we go. And go to files. And lecture notes. So like if we look at lecture number 2. Boom. Second. We're still waiting. There we go. So here's the entire lecture. That was the first page. But you can download this file. It's a PDF file, and it'll go through all the notes. And from there, you can pick out the quiz. And this thing's so slow.
Do I just send you a document of what I could comprehend, or
What's that?
I saw that I have to send you something on quiz 2 and exam 2, but do I just give you a document on what I could comprehend from it, or am I still way off?
Well, let's see here. I'll pull up the actual file here. This is the thing I was just showing you is the lecture notes from last time. So if you download it, you can open it on your computer. Computer's so slow. So you can see right here at the end of it, here's exam number 2. And at the beginning of the notes somewhere is going to be quiz number 2. Okay, so if you miss class, you can always get the exam and the quiz out of the lecture notes. Okay. And
For quiz, for exam 3, will you have a slot where to put it on later on tonight, or?
oh yeah, I forgot to do that, didn't I? Let me
Yeah, because I don't see it on there.
thanks for reminding me. Let me just get there.
So do I just do those and then send it back to you?
You upload it in Canvas. Let's see. Let's go to Canvas.
I hope I'm not asking too much.
No, it's fine. See, what is the date? 27th. Okay. Let me get the. Let's see.
I didn't do so well in my last math class either.
That's all right. Number 3. Exams, 2. There. Yeah, you should be able to go to assignments. And let me get the student view here. Yeah, you should be able to go to your assignments, and then here's your quizzes and your exams. You should be able to upload those.
Oh, okay, so when I do complete, I do upload in those slots.
Yeah, the quizzes and the exams you upload in Canvas. Then the homework is done through Alex.
Okay. Sorry, I just got so confused.
Let's see why. Yes, I guess I have overdue ones here. I don't know what this is. Homework, etc. Yeah, so yeah, you should be able to get the quiz and the exam in class every day. If you miss class, you can download the lecture notes and get the quiz and the exam out of there. And
Okay, thank you so much.
later on, I always post the solutions to all the exams and quizzes. So since we're at the beginning of the semester, just go get all your quizzes and exams in before tomorrow night, before Friday night. Okay,
Mhm.
so you can get full credit on them. Okay,
Thank you.
sure.
Those videos, those mini videos you show us, do you know how we could find those too?
Those are in Alex. That's should show up in modules, I think. If you go to Canvas and modules,
Yes, sir.
there's Alex. All right. That's where you go to load Alex. And that's where I go to get the textbook. All of this stuff. This is your textbook. So the module there gives you a textbook and the homework is inside of it, I think. Where are you somewhere?
I'm still learning how to use that too.
Yeah, this is the first time I've used it, so it's new to me as well. But yeah, just spend time playing with it. You only learn it by trying, you know. You gotta
Mhm.
spend time. It's like hanging out at the river, you know, and flipping over every little rock and seeing what's under it. Gotta spend some time exploring, you know. Try to make
Okay,
it
yes,
your
sir. I'll not give up just because the first 2 weeks are a little fuzzy, you know.
name. That's good. Yeah, you stick with it, you'll do fine. You know, the thing about math
Yes, sir.
classes is if you give up and then try to take it again the next semester, it's just as hard, you know. You're better off
Mhm.
trying through the whole semester. And if you don't do great, so what? You learned a lot. And the next time you take it, you'll probably do a lot better, you know.
Yes, sir. Well, thank you so much for your time.
Sure. No problem.
Well, take care.
I will